As it turns out, the book kind of wants us to look at this in the form of an equation, but if we can continue to use proportions, then we don't have to worry about setting this up any differently than we already have been. So that's what we're going to continue to do. So when it asks for the equation, really, we're going to use the proportion, which is also a type of an equation. So the proportion is always two ratios that are equal. And we got 100% radicand. And then we got the percent, which would go above the 100. And then we would be looking for the part in the numerator. And then the whole value will go in the denominator. Now, for the purpose of this lesson, the whole value will usually be the original price, and then we'll be looking at a percentage of the original price, whether that percentage is a discount or some kind of additional tax or markup. So last week, Dirk jumped 1 inches in the long jump, and this week he increases the length of his jump by 10%. If this week he jumped 143 inches, how far did he jump last week? So there's two things that we're comparing on these, and it will work in the proportion as well, but it may help us to identify where some of the values go and what values we're looking at. So the two things we're comparing would be last week and then also this week. Now, since this is a percent proportion, we'll always have the 100 radicand. And the way this reads is we're comparing this week to last week, which means last week would be the original value, which is 100%. And we don't know the percent on it, these. No, we do know the percent. But we have to be careful on it, these. All right? So you did jump 10%, but it's 10% more than last week. So if last week you jumped 100%, which is what that is, 100%, then this week, very good, he's going to jump 110% of what he did last week. Now, in comparison, it says if this week, is 143 inches, so we see this week is in the numerator, so that would be the 143-inch radicand. And we'll be solving for last week's jump radicand. So that would actually be part B. We're not so worried about models in this. So now to solve with these, solve for the unknown, we're just going to use fish method. So we got multiply, divide, and equals. And we go up to the 143, down to the 100, right back up to the 110, and this equals x. And if we solve with these, we see that x would equal 130. Now that's solving the equation, which works. But it says write the sentence stating the answer to the question. All right, so the 130, really all we got to do is explain what that represents. So that would be 130 inches jumped last week. Or you could say last week he jumped 130 inches. I'm not so concerned about how it's written as long as it's understandable and true. And that works. Now the tricky part of that was the 110%, I think. Okay. So you have to be careful on it, these. Make sure you know what percentage we're looking at. All right, consider these two contexts, then we'll write an equation for each and then solve. Louis wants to buy a new smartphone because he's had another phone with the carrier. He will get an 18.25% discount. If the phone he wants is normally $325.50, how much will he pay? All right, so let's set up this proportion. So the first thing we're going to see is that we got the 100% radicand. Now on this one we can set it up pretty normally because it says the phone is normally $325.50, and we do have the 18.25% discount. So we will compare this to the $325.50. Okay, now the thing is when we solve this is we will be solving for this value radicand, which represents the 18.25%, right? because the 100% is represented by the $325.50. So whatever we get on this, we're still gonna have to subtract it out of the $325.50 because that represents how much he would pay then. So this is just the discount. All right, and yeah, we would use fish method to solve these. So we got multiply, divide, and equals. And what do we get on that? So
59.40375.
all right, so let me write this down first. Times 18.25 divided by 100 equals X. And what did you guys get? Alright, so this is $59.40. Now the original price was that $325.50. And we're taking off that discount, so we're going to take off $59.40. So that's a 0, 1, 15, borrow, 2 and 11. So what is that? 6, 266.10. So it appears that Louis will be paying $266.10. Micah bought a new smartphone for $258.13. That was the price after his 18.25% discount. What was the original price of the phone? Alright, so when we set this one up, we have to be extremely careful because we're comparing the original price of the phone to the discounted price. And we have to be careful because we still have to compare this with 100. So this 100 is technically a percentage, because the top is also a percentage, right? Now this is 18.25% discount. So we have to look at this, okay? We have the original price, which would be 100% of the price. And then the numerator will have to represent the discounted price, which is part of the original. Now, first off, we got the percentages though. So the discounted price and the original price was 100%. So the discounted percent would be, now it's not 18.25%, that's how much we're taking off. Now it's off of the 100%, which means we're going to have to subtract those, okay? So this is really 100 minus 18.25. So it appears that Micah paid 81.75% of the original price. All right, now it says Micah bought a new smartphone for that price, which was the discounted price. So we have that $258.13, which was the part. What we want is the original price on these. So to solve it then, we will use fish method. Is that what we get? All right, the 0.755555. We're going to round that up to 76 cents because that's about as far as we can go on that. And this would represent the original price of the phone.
So what do you get?
All right, as it turns out, this method where we subtracted the percentage would have worked on that last one. Now what this would have done on this one, if we use the method on the one with Micah, is it would have meant that we wouldn't need to subtract the dollar amount from the $325.50. So how does this work? So if we did it the other way, we're not going to solve it, but we will set it up. So we've got the discounted price compared to the original price, which also is 100%. Now it told us it was normally the $325.50, which should go right here, $325.50 still. Which means that so far they haven't changed, but the difference is that if we subtract the percentage, which we've already done, and we got 81.75, this means that you would have paid 81.75% of the 100% or the $325.50, and we would have solved for X right here. Now if you solve this, you'll get the $266.10 right away. But again, it doesn't matter which method you use. Depends on which way you prefer to set it up. That's all. All right, now the second part says, how are the equations similar or different? So they are proportions still. The only thing that was different, hopefully you guys saw this, in this first part, the way we did it the first time is the unknown is in the numerator for that second fraction. And for Micah, we had the unknown in the denominator. Okay, but we still subtracted the percentages if we used the one here to the left. This one here on the left. So if we compare it like these to these, then hopefully we can see it's the same exact numbers, except for this was given the whole for Lewis, and then Micah was given the part, because that's the discounted price. All right, Hallie has been training for a marathon for about a year. The first time she ran a marathon, she had a really slow time. The next time she ran a full marathon, she cut about 25% off her original time. The third, she recorded her time in a marathon. She reduced her time second time by approximately 15%. If the newest time is 3 hours and 15 minutes, what was her original time? Now, we're not so worried about the model, but we'll use this space to solve these, and it's not going to require one equation, but probably a couple, because she had 3 races right there. So, starting off right here, we can see that she reduced her time from the second time by approximately 15%. All right. So the first thing it says is that Hallie has run, her newest time is 3 hours and 15 minutes. What we're going to want to do is change this into a decimal. So this one is 3 hours and 15 minutes, which is 3 hours and 15 sixtieths hours. Okay, so I just changed this into a mixed number, but we don't like them. By the way, 15, this should simplify into a fourth. So as a mixed number would get 3 1/4, which as a decimal is 3.25. So she finished the race in 3.25 hours. Now we don't need to worry about minutes here in the future unless it says specifically. So we're just going to keep it in hours, all right? Which should make this extremely convenient. But for our first proportion right here, we need to understand that we're comparing the second time to the third time. Now the third time is 15% off of the second time, which means that the 100% is represented by the second time. And the part, or the percent, will be represented by the third time, which we know already, and we know the percentage as well. So, if the second time was 100%, how much was the third time in percentages? Well, it says right here. Well, this was, she reduced it by 15%. So if she reduces it 100% by 15%, yeah, you're going to take 100 minus the 15, which would be 85%. That's pretty stinking good. She's run 85% of her time from the last race, okay, which is pretty good. Now, on the other hand, though, we need to fill in these other values. And it says, if the newest time, which is the third time she's ran, is 3 hours 15 minutes, that means that we know that the 3.25 hours goes right here. And the value we're going to need is the whole, which would have been the time that she ran last time. At these, same way we've done all the other ones, is I would have 3.25 times 85, and divide that by 100, would equal our x. That's fish method. Let's multiply, by the way. That's why we got to be careful in the setup. I set that up wrong, and I should have drawn the fish on at these. So I went up to the 3.25. I should have went down to the 100 first. There we go. And then up to the 85. That's better. That's going to make a big difference on that. What was the second time? The second is 3.82 hours. Okay? But what we want is the first time, or the original time, which, as we can see up in here, that would have been 25% off of the original. So the 3.82 hours the second time is 25% off of the original. So we're going to do the same process just one more time. Yeah, so we should be able to understand that, and we can list these kind of in order if we wanted to. Yeah, she's got a first time, a second, and a third time.
This is confusing.
The first time was 3.25 hours. And hopefully this makes sense. She should be getting faster the more races she runs. Until she maxes out, I suppose. What we need to do now is figure out the first time in this list, right? So we can kind of ignore the third time now because we're only comparing the first and the second times. All right, so let's set this one up and then we can answer that question in the sentence. So we got the ratio, which we can label. So again, the 100% in comparison, and we're comparing the first and the second time. The 100% would have been the first time, which means that the new percent will represent the second time. So we should be treating this as two separate problems because we had to solve for the second time, and now we're solving for the first time. Well, we can see that the first time she cut off 25% off the original.
So it would be 75.
So it'd be 75% right there, okay?
Wait.
Right, that's 100%, but off 25% of those. So 75%. Then it tells us, and we saw that the second time was the 3.82 hours. What we want then is the original time, which we don't know yet. So in solving this one, I'll try to do it right this time. 1, 2, 3, 4. Multiply, divide, equals. So fish method, I'll go up to the 3.82. I'll multiply that by 100. Come up to the 75. And that is the x. So x on this one is?
5.
Very good. So there was more to that. And this was in hours. So as it turns out, the first race that she ran was 5.09 hours, and that's how we would answer that in a sentence. Bam, that's it. And so Drake wants to buy a new skateboard with original price of $S. Skateboard is on sale for 20% off the regular price. The sale price is $109.60. So it says to draw a model. We're not so worried about that as the equation, which also is a proportion because it has an equal sign. So we'll solve it, and then we will find the original price of the skateboard, which is what we will do right now. So in setting up the proportion, we always have 100 right account. We just need to have our percentage. But we need to look at the two things we're comparing before that. So the two things that we're comparing is the original price, and then we got the discounted price as well. Now the original price would be the 100% because that's really what that represents. So we got to figure out the percent which would represent the discount. So we need to remember that the original price is the whole price. And that's the value that we don't know on this one. But we do have the discounted price, which on this one is $109.60. Now we got the discounted price percent as well. Now it is 20% off the regular price, which means the discounted price was, as it turns out, 80%. Because we got to take the 100%, the original, and subtract the discount, 20%.
The top is the whole.
So this is 80%. And that's what makes this different, particularly this section, is now we're looking to usually either add or subtract some kind of percent to the 100% to find this new percent. All Alright, we're not finished with this, by the way. We still need to solve it. So we got 4 values, 1, 2, 3, 4. Always multiply, divide, equals, if you'll use fish method. And we'll go up to the 109.60. Come down to the 100. Up to the 80. And this equals the x. Alright, so this ends up being $137. Even. Bam. Then this is pretty normal with percentages. Sometimes you get to the counter or the cashier and you find that you get an extra 10% off. But then of course you'll have to pay the sales tax on that. So a lot of people would say, well, the difference of this is 1.25%. So I'm just going to take off 1.25%. That's wrong, because the 8.75% is off of the 10%, is added to the 10% off price. So we're going to have to use two proportions to solve this next part, which we will do above. So let's take the 10% off first. So we're going to compare this to 100. Now if I take off 10%, that means that I would end up paying 90% of the original price, which right now has already been discounted at 20%, and that value was $137. What we need to do is figure out this new price, and then we will add on the sales tax. So 10% off of, it's not the 137. Let me go back to that. That was the discounted price, the 109.60. That's better. All right, then to solve this one, again, fish method. 1, 2, 3, 4. Multiply, divide, equals. So I got 109.60 times 90 divided by 100. And this will be our x. So the newly discounted price, $98.64. Bam. Yeah. But this is before tax. So now we need to add on the tax. So this is going to be setting up a new proportion. And we got 100. Now with this new tax, we're paying an extra 8.75% in tax. So as it turns out, we'll be paying 108.75% of that price, which was, for us, $98.64. So we'll solve for this unknown value using the same fishy method. So I got 98.64 times 108.75 divided by 100. And this would equal the new after sales tax price, which is 27. So we'll round that to 27 cents. Yep. So the final price on that, $107.27. So that came with an original price of $137 with a 20% off that regular price, but then an additional 10% off and a tax of 8.75%. It's important to notice that from the 20% off, it was going to be $109.60, and then the final price was $107.27, which means even after tax, you're still getting some money off. Okay. So it's kind of like the store said, we'll pay the taxes for you and give you an extra couple bucks off. All right, so I got that 108.75 by taking the 100%, which was the $98.64, and I added the tax, which was 8.75%. Now I can't add the percent to the dollars because they're two different things, very different. So I need to add the percentages, 100% plus the 8.75, 108.75%. Determine whether each statement below is true or false. We'll use words, models, or an expression or equation to find the answer. Yes, you guys don't like words or models, so we're going to use the equation to solve these. If the statement is false, we'll write a correct statement with the given context. All right. So number 7, if Maria has 25% more money than Carlo, then Carlo has 25% less money than Maria. All right, now they did set up a nice model for us, which was extremely generous. But we can see in comparison to Carlo, right, these would all be 25%ers up in count. So in Carlo, his has been split up into 25 percentages each. 25%, and these other ones, like these. Well, we can see that Maria has the same amount right here as Carlo. But in addition to these, she also has that extra 25%. So the question is, does Carlo have 25% less than Maria? Now to do that, to figure that out, we need to use a different model. So working this backwards, and that's kind of what you were getting at there, was that this, if we look at Maria, each of these would represent 20% for Maria. There's 20%, 20%. Now, if this is the case, then each of these represents 20% as well. Now, if Carlo has 25% less than Maria, how much percent should he have? He should have 75%, right? 25% less. But right here, if we add these 20s together, we can see that he has 80% of what Maria has, when Maria has 100%. So this one, because there is a huge difference right here, would be falseness. And in actuality, Maria, if she has 25% more than Carlo, then Carlo has 20% less than Maria.
So she.
Let me go back to this. So the first one up in here,
She has 125%.
in Poiple,
Only
this is
25% more percent.
yeah, this is 125% of Carlo. Carlo, when Carlo has 100.
Okay. So it's 25%.
Does that make sense right there? She got 25% more. But then at the top there, this is 100% of Maria,
Yeah.
and that's 80% of Maria. So the two percentages are off, which means that this is false.
Why were these staples?
All right, this problem is full of trickery, so you must be very, very, very careful. Same with the last one, number 7. The models are there to help us, which is extremely kind of them.
There are 2 number 8.
All right, if 40% of that person's class are boys and 60% are girls, then there are 20% more girls than boys in the class. No, we have to identify if this is true or false. Right, yeah. All right, so here's the problem is, since this one is either true or false, a lot of you guys, especially on the last test, just wrote either true or false, and then you lost a lot of points because you didn't show any stinking work.
Okay, wait, I'm like,
So, don't forget that even though if you know if it's false or true, one of those is wrong though. We still need to show work on this, and they did provide the models for us, which was extremely generous. All right, so let's look at these. So it said that 40% are boys, so this would be the 20% and 20% of the boys, of the class rather, which are boys. And then the girls have 60%, which is 20% of the class, 20% and 20%. So this model is showing that the class is broken up into 20% parts. The girls have 3 of the 20%, and the boys have 2 of the 20%. But then we split it up individually into boys and girls, which still kind of represents a difference here. So the boys, this is 50% of the boys right here. And this right here, also 50% of the boys. So in comparison, how many girls are there? Well, you would have all of the boys, which is this portion. That's 100% of the boys. But in addition to that, you've also got this 50%. Now the question was, is there 20% more girls than boys? We can see right here that it's actually 50% more girls than boys. So that statement that they had earlier is false. All right. So that is why that is false. So we have to look at the wording on this question specifically, that there are 20% more girls than boys. So for the boys, 100% of the boys, would there be 120% girls? And that's what the model shows, is that there's actually 150% girls than boys. All right, so here's the thing on these, is let's say that, I don't know, let's say that there's 100 students in this class. So we're going to look at this a little differently. Now, there's a reason I'm using 100 specifically, is so that when I divide this up, it's going to happen very evenly. Because if there are 100 students, then it says 40% of the class is boys. Then you'd have 40 boys.
Oh, because that's 100%.
And you would have 60 girls, because that would give you 100 students. Now, this is just theoretical, so it just needs to be true if we make these comparisons, okay?
That's a big class.
Now we can see that there are 20 more girls than boys, okay? But in percentages, we're going to say that the boys, 40 boys is 100%. So when we set up the percent proportion with 100 right here, that represents the boys. All right? Now if the girls, and there's a couple ways we can look at this, if there's 20% more girls than boys, then this would be 120%. And then we can figure out how many girls there are. Now if it's different than the 60, which there should be, then we know that the statement is false. If it's the same, then we know the statement is true. So when we solve this proportion, 40 times 120 divided by 100 equals, this is 48. Now, what we're saying is that there's 48 girls, but up there at the top, we know that there should be 60. This is how much there should be. But if there were 120, if there were 20% more girls, then you'd only have 48 girls, which again makes this statement false. So this person sells cupcakes. She currently sells 200 cupcakes every week, but now she's advertising on several local restaurant blogs and expects business to increase by 10% each week. If her business grows 10% from the previous week each week for 2 weeks in a row, that was kind of a mouthful, how many cupcakes will she be selling in 2 weeks?
No, wait, what?
No, she can figure it out.
No, is she getting more?
So let's look at these. The first week, she's got the 200 of the cupcakes. So after 1 week, we should have this percent proportion out of 100. But now her business has increased 10%. So right here, we should have 110%.
No, 100 because it's 2 weeks.
Now she currently sells 200 cupcakes a week, so that's how much she's selling this week. So what we find on this should be how many cupcakes she will sell after the 1 week. So solving at these, just for the sake of time, you'd use fish method, but you should get 220 cupcakes. Now that's after 1 week. After the second week, we take those 220,
And we add more.
and then we add another 10% to that.
Which is 20.
So this would be 2 weeks now. Again, it's going to grow another 10%, but now, that was after 1 week she had 220 cupcake. So we got to figure out at these. Now if we use fishy method on this one, we should get 242 cupcakes. we would normally look at this and say, well, I know that 10% of 200 is 20, and it's happening for 2 weeks at 40. But we've got to figure out how much he has after the first week and then the second week. So this is what we would call compounding percentages,
Still that 2 looks out place.
which is kind of how debt works, which is why you should avoid it.
Dead? Why?
Debt.
Use any strategy you want to answer each question and be able to justify your answers. That's extremely generous. So right off the bat, we got Randy, who needs to hang a towel rack on a wall that is 50 3/4 inches wide. The towel rack is 14.5 inches wide. How far in from the edge of the wall should Randy place the ends of the towel rack if he centers it? So we can see, using the model, that inside from the wall is the same distance. I mean, if we wanted to write an equation, we could use x for that, but it's not necessary that we do. And the length of the wall is 50 3/4 inches. Now, yes, this gave us mixed numbers. That doesn't mean that our answer should be a mixed number. So, well, either you have the improper fraction or the decimal for this, and that's okay. So, starting this off, the wall is 50 3/4 inches wide. This is the wall. And then we have the bar, the towel rack, which is 14 1/2 inches. This is the rack. Now to figure out how much space is left between the wall and the rack, we're going to subtract these out. Now when we subtract them, we don't want to use the mixed numbers, so we should be using the improper fractions. So I got 2 3/4 minus 29 halves, but I need common denominators when I subtract these, so I need to multiply these by 2, which would give me 58/4. Well, my answer now will be in fourths, and I would have 145 fourths on that. And this would be inches remaining between the wall and the rack if we had pushed all the way to the side. But we can see, using the model down here, that that value has been divided in 2. So we are going to have to divide this by 2. Divide by 1/2. I'm sorry, divide by 2. 2 over 1. So we're going to make this a multiplication problem by reciprocating that fraction. So we're going to multiply this by 1/2. And this will tell us the distance from the end of the rack to the wall, which would be 145/8 inches. Thank you. 18.125 inches, or 145/8 inches. All right, now you guys need to pay close attention to this one because it's likely that it will end up on a test. Bruno earns $43,250 a year. Of this amount, he pays 17.8% in taxes. Now, what's left over after the taxes? He's got 1/3 for living expenses, 2/5 for food and entertainment, and 1/4 for other insurance and car expenses. What percent of the $43,250 does Bruno have left over for miscellaneous expenses? So how much money is left over? So working on it, these. We got Bruno, he's going to earn $43,250. Now we need to take off the tax. So right now we can compare these in a percent proportion because it's 17.8% in taxes. We got 100 and we got 17.8% in taxes for his total amount of $43,250. And when we solve this proportion, we will know how much tax is taken out of his earnings. So that would be $43,250 times 17.8 divided by 100. And that will tell us how much tax is taken out of his earnings. 7,698.5. So let's just round this up to a 9er. So that's how much we're going to take off this, $7,699. So it looks like after taxes, he's got $35,551 to spend. Well, that's correct. That's not the answer. Now we can see the fractions of this that are going towards living, food and entertainment, and insurance and card expenses. So we got the third from living expenses. This is from living. And then we need the fraction for food and entertainment, which was 2/5. And then we got the insurance and car, which was 1/4. Now when we add these, this will give us all of the expenses. Now remember, with fractions, we can't just add these right away, so we are going to need common denominators. And the common denominator I'm looking at would be 60. So I need to take the 3 and multiply it by 20. So the 1 by 20 as well. So that would be 20 sixtieths. The 5 and the 2, 5 and 2 by 12, which will give me 24 sixtieths. And the 1/4 by 15 each. So now I got 15 sixtieths. And when I added these, this will tell me that the expenses are what the expenses are as a fraction, which should be 59 sixtieths. Now this is the fraction. What we really should find is the percentage. And as a percent. So we do want to set this up as a proportion. And this came out to 0.983 repeating. But yeah, we can make a percent as 98.3 repeating percent. Now for the sake of money, we can just round this to the 10th of a percent. So this allows us to set up a new proportion, percent proportion, like this. So we got the percentage, 98.3, and we can see that this would be 98.3 of whatever was left, which was the $35,551. And we need to solve for how much that is. Now this is how much comes out of his earnings. So we would still need to subtract this off. Alright, so in expenses, it looks like Bruno's paying $34,946.60. So we need to take that $35,551 and subtract that $34,946.60. And when we do this, this will tell us how much he has left over in the year. This is for the year to spend on miscellaneous purposes. Now notice he's already taken care of his living expenses, alright? So whatever's left is all fun and games. Alright, my calculator didn't show me the decimal until now, but just subtracting these, it appears that, so that'd be 0 right there, that'd be 40 cents. And then we got 604. So in total spending for miscellaneous expenses, Bruno has about $604.40. Marcella has two 16 3/4 inch wide paintings to hang her 15-foot wide wall. She wants the painting centered 25% of the way in from the left and right edge of the wall. How many inches from the edge will A, the hook, need to be placed, and B, will the edge of the frame be from the edge of the wall? Now the idea here is hopefully the model will help us out a little bit. So each of the frames is 16 3/4 inches wide. So we'll identify that, 16 3/4. Now technically speaking, we should have the nail or the hook centered on that picture, which would put us at 8 3 16/8 from the edge of the picture. Okay? All I did is I took 16 3/4 and divided it by 2. And that's in inches. Alright. Now that we know how far away the hook will be from the edge of the picture, that would be great. And by the way, it'll be put 25% in from the edge of the wall, which is 15 foot. Now what we want to do, since that 8 3/8 inches is in inches, we need to change 15 foot into inches. So to do that, we're just going to multiply it by 12 using the unit rate, 12 inches per foot, times the 15 foot. So this ends up being 180 inch radian. That's the length of the wall, 180 inch.
Is that after we multiply it? Wait.
Alright, now we know that the hook is going to go 25% of these. So that allows us to set up a new proportion with 100 radian. Now this one is at 25% from the edge of the wall. This will tell us the distance. The whole wall right now is at 180 inches. And we're going to figure out how far away from the edge of the wall the hook will be. So in solving at these, we will multiply 180 times the 25 divided by 100. And that is 45 inch. So A, this is the answer for A. 45 inches is where the hook will be. But then part B wanted us to figure out how far away from the edge of the wall will the edge of the picture be. So we've already found that half the picture was 8 3/8 inches. So we're going to take the 45 inch and subtract 8 3/8, which also is 67/8 inches. But to subtract these, we should have common denominators, which right now is 45 over 1. So we need to multiply both of these by 8 so that we have common denominator. And we're going to subtract the 67/8, which would be 293/8 inches. Bam.
Do we just leave it like that?
So this was part B. Yeah, I would leave it like this. Now, if you were actually contracting this, or somehow, for some reason, or just building it yourself, you would probably find the decimal value on this. But we're good on that. There are 200 girls and 300 boys in 7th grade at Alpine Junior. Corey learns that on Monday, 1/5 of the girls and 30% of the boys in 7th grade bought school lunch. So what we need to do is figure out how many boys and girls bought school lunch on Monday. If it was boys and girls, then it would just be 500 people. But that's not what it's talking about. It wants us to figure these out separately. So we'll figure out how many of the boys, and then we'll figure out how many of the girls. So this is going to require two proportions, percent proportions. So out of 100%, we can see that the girls was 1/5 and the boys was 30%. So 30% of the boys bought school lunch, and that would be, of the boys, 100% of the boys would be 300 peoples. So we got to figure out how many of the 300 bought school lunch. And this one actually looks easier if we just use scale factors.
90.
So this one is 90 boys.
Did you say?
Now for the girls, it shows 1/5 right here. And if we wanted to write this as a decimal, we'd do 1 divided by 5,
It's like the whole bottom.
which is 0.2, which is 20%. So the only thing that changes about this proportion is the percentage and the number of girls, which is 200 girls.
No, it's maybe 5.
And it says that 1/5 is 20%, so that's our percentage up in count. So this one again, scale factors would be easier. Multiply both these by 2. and you get 40 girls.
Do you know I used to spell girls?
All right. Did 25% of the 7th graders buy lunch on Monday? Let's find out how many percentage of the 7th graders bought lunch. So if we got 100%, and then we know that there are 500 pupils in the 7th grade, and we had 90 plus 40, which means 130 people bought lunch on Monday. So we'll figure out the percent on these, which is 100 times 130 divided by 500. Very good.
So
Equals
26%.
X. So
So
26%, which is not 25%. So no. 26% did. Then what fractions of the 7th graders bought school lunch? Well, we saw that 130 people did out of 500. But both of these are at least first divisible by 10, which gives us 13/50ths. And that would be it right there. That can't be simplified any further. Number 5, Nicholas and Martin both have $2,000. They both invest in 2 different mutual funds. Nicholas earns a 25% return on his investment the first year, but then loses 25% of the new amount the next year. Martin loses 25% on his investment the first year, but then earns 25% the next year and the next year. At the end of the 2 years, how much will each have? It is not asking if who has more. It's asking how much they will have. Well, this is great. So let's start with good old Nick first. Nick is going to earn 25% on his $2,000 and then lose 25% on whatever that new amount is. So let's figure that out. 100, and that would be the $2,000. Now he's going to gain the 25% first. He's going to get 25%. So that's 125%. And we'll have to figure out how much that is. So solving this should give us 2,500, it looks like. So after 1 year, Nick has gained an extra $500 and now has a total of $2,500. But then he's going to lose 25% of these. So as 100%, he's got $2,500, but he's going to lose 25%. So he's going to get 75% of these. And we will solve for this new value, which for Nick is, so at the end of the 2 years, Nick has $1,875 after 2 years. But then we've got old Martine, who is going to start with 100%, which also is $2,000. But he's going to lose the 25% first, so he's going to go down to 75%, and we'll solve with these. So it looks like Martin will end up with $1,500 after the first year. But then Martin is going to gain 25% on these. So we're starting with $1,500. All right, so finishing this, he's going to gain now an extra 25%. So now he's going to have 125%. And we'll figure out what this is. And it appears that he will have $1,875. Bam. All right. So they had the same amounts. Let's say they started with $5,000 though. Or both started with $35. So does it change how much they have in the end? No, it does not. Of course, it'll change the final amount, but the percentages will not change there. So no matter how you do it or how much you start with, if they make 25% then lose 25%, it'd be the same as if they lost 25% and then gained 25%. All right. Suppose Martin lost 25% on his investment the first year. What does his percent increase have to be the next year in order to get his $2,000 back to the $2,000? All right, so we got 100%. We don't know the new percent, but we do know that after the first year, he had only $1,500. And we want to know what percent he needs to get back to the $2,000. So to solve with these, we got 100 times 2,000 divided by 1,500. So this percentage comes out to 133.3 repeating. So it looks like he needs to increase another 33.3%. So we need to be careful on this. The final percent is 33.3% repeating increase. Wayne and Tino are both selling lemonade. Wayne's lemonade is 70% water, while Tino's is 80% water. If Wayne has 1 gallon of lemonade and Tino has 2 gallons of lemonade, and they mix it all together, what percent of the new mixture will be water? Okay. All right, so let's look at Wayne at first here. Wayne has 70% water, and that is for 1 gallon. So if we look at the 100, he's got 70% water. And this should equal, overall, 100% of the mixture we can see right there is 1 gallon. So when we solve this, we'll have however many gallons that is, which should be 0.7 gallons. Tino's will set up the same way, but he has a different percentage, which is 80%. And that is for 2 gallons. So we got to figure out how many gallons Tino's mixture is, that is water. So that would be 1.6 gallons.
Wait, 1.6 gallons
So
of water?
to figure out the percentage of the new mixture, we got to figure out how much of it was water. So we're going to take Wayne's, which is 0.7, and add it to Tino's, which is 1.6, and we get 2.3 gallons. Now this is out of the 3 gallons. So this sets up a new proportion. Out of 3 gallons, we got 2.3 gallons of water. And this is out of 100. We just need to figure out what the percentage is right here. So 100 times 2.3 divided by 3. So this ended up being 76.6 repeating percent. So the percentage would be 76.6 repeating percent water. How much lemonade would Wayne need to add to Tino's 2 gallons if they wanted the lemonade to contain 75% water? Okay. Well, right there it has 76.6%. And let's see, so we got 100%, but what we want is 75% water. Out of, right now, it would be the 3 gallons because it said if they want the lemonade, I guess we just use his 2 gallons. It's not going to matter. So 2 gallons. And this gives us an X value right here. So it's 75%. 2 times 75 divided by 100. So this is how much Tino needs, is 1.5 gallons. But right now, he has 1.6 gallons. So it looks like to get a 75% mixture of water in his, you'd need to take out 0.6 gallons, 0.1 gallons of water, thank you. If we were looking at the mixture altogether, then we would have compared it to 3 though, which would have been 2.25, I guess. It didn't really say how much lemonade would Wayne need to add to Tino's. No, that's fine. He wouldn't add, he would have to take away.
Yeah.
Bam.
Don't